All right, we're going to do a few problems here on page 202. I'm going to start with number 46 here. They give you some vertices, point G, point H, and point J. They tell you that triangle KLM is congruent to triangle GHJ, and then they want you to figure out the length of KLM, KM. Now, with these original vertices here for GHJ, I plotted those first on this graph paper here, and from there some of these lengths are easy to figure out. So G to H is 1, 2, 3, 4 because it's right there on the graph paper straight up and down. So GH is 4, left to right HG is 1, 2, 3, and G to J is going to take a little bit of time here to do because we're going to use the distance formula on that. But now when you come back to this problem, the actual problems here where they ask you, okay, what's the length of KL? Now they don't even have a picture, but they do mention that these two triangles are the same, even though I haven't even drawn triangle KLM. The first two letters should match up with the first two letters here. So if GH is 4, KL is also going to be 4. LM is the second and third letter being HJ. So if HJ is 3, then LM is 3. Now the one that is going to take a little bit of time to calculate because there's no tick marks going diagonally is G to J. You could use the graph paper and do a squared b squared c squared. In fact, this is a right triangle right here. We can just go a squared b squared c squared, or we can just use the the distance formula to figure out the distance between G to J. G to J, which would be the same as K to M. So if I just take this point and this point and use the distance formula where I subtract the x's, square it, plus subtract the y's and square it. So for this particular problem here, you will go x2, I'm using the top two, this is 1 and negative 2, we'll square that, plus we'll subtract the y's, 3 minus a negative 1 here, and we'll square that. What we have here is the distance formula, 1 minus negative 2 is 3 squared, plus 4 minus negative 1 is 4 squared. 3 and 4, which is 9 plus 16, which is square root of 25, which is 5. So this distance here to here is 5, which makes the answer K to M, which is the same as G to J. G to J, K to M is also 5. I used the distance formula to figure that out. Some people will recognize the fact that you could have just used, this is a right triangle here, this is 4, this is 3, so a squared, b squared is equal to the diagonal squared. Here's the 4, here's the 3, and you get the same result using the distance formula or Pythagorean theorem. Okay, I'm going to move on to number 40. Says, just reading the book, it says, if L and M have coordinates L, 3, negative 3, M, 6, negative 3, how many pairs of coordinates are possible for K? So we're going to figure out answers for K. We're going to put this on graph paper. Let's also remember that these two triangles were equal from the previous work. This triangle here, which is GHJ, H to J is 3, G to H is 4, and when we did problem 46, we figured out this to be 5. And so, again, if I go G to H, up and down, which is 4, by the way, that is the first two letters, that's the same as K to L, which is also 4. H to J, I'm just putting this information down here, is the same as, that's the second and third letters, so is the same side length as A to L to M, which is 3. And finally, I don't even know if we need this, but G to J, which would be the same as K to M, which is G to J, 5. So what we're going to do is plot these new points here. Keep in mind that the two triangles are congruent. So what we have here is L and M, 3, negative 3, 6, negative 3. And the question is, where do I put K? And you need to realize this is the 3. LM is the same as HJ. And we're going to put K somewhere where it is 4 spaces. I'm looking at this real quickly here. From point L. So you can go 4 spaces above it. If I put a K here, this is a possibility. This would be 3 over 1 up. And this, of course, would be 4 spaces. KL, LK, excuse me, is 4. KL is 4. Or you can put 4 spaces below it. 1, 2, 3, 4. 4 this way. This could be a possibility. This is 3, comma. This is another option here. 3, comma, negative 3, negative 6, negative 7. 3, comma, negative 7. There's another option. And this would give you a 4. LK this way or LK this way is 4. Now what you don't want to do is this in pencil. Don't go, well, why can't I go 4 spaces up from here, M, and put a K here. Now this is wrong, because KM, although I count it to be 4, KM, looking back, KM should be 5. This is really the diagonal one. KM should always be the one that's diagonal, not this one that's only 4 spaces. So don't put it up here, don't put it down here, 4 spaces. You are going 4 spaces from L, because KL is the one that's 4. KL is the one that's 4, not KM. So don't go 4 spaces from M. So I'm going to erase this here. Okay, so there's 2 options where you can plot the points for K and still be congruent. That would be 3, negative 7, or 3, 1. And if you want to complete the triangle, it could be this triangle here or this triangle here. Both are congruent to this one, the original.